Okay, this is week 8, and thank you for your hard work up to now. And this week we'll touch risk and return concepts and the lessons from market history over last 8 years. If you see here, treasury bond, treasury bill means government, right? So this is very safe, but low return. Large company stock and small company stock. Large company stock is at least safer than small company. So in here, up to this amount of risk and then return. And small company stock, the highest return, but the highest risk. In finance, we use a standard deviation. We'll touch it a little later. This standard deviation as risk measurement. So this one shows historically less risk if you take, then less return. If you take more risk, then more return. Typical risk and return relation. More risk, more return, less risk, less return. Okay? And over 80 years, the large company stock 12%, small company 17%, government bond around 6%, treasury bill 3.8%, little over inflation. So that reflects more risk, more return, less risk, less return concepts. And then here, if you take a look at the normal distribution, if you have enough sample, then bell-shaped normal distribution curve will happen using over 80 years data, okay? And then average is 12.3, and the highest one around 73, the lowest one around 48%. Another way, over 80 years, if you invested in large company stock, then the best year you enjoyed almost what? 73% gain. Great, right? But worst year, you lost almost half. How we can see here, that's using this bell-shaped statistical theory. We have from 0, that's average 12.3. If you multiply 3 times standard deviation, this is 20.32% or risk, okay, volatility. 3 times 20.2, here 3 times 20.2, that ends up 73%. Or the worst year, minus 3 times the standard deviation 20.2, you're going to end up almost half losing. So 99.7%, that means almost every time, right? Almost every time your return will be between losing half and gaining 73%, not beyond, not further down, okay? Then what if you don't want to lose, okay? You don't care much about earning, but you don't want to lose. Very conservative person. Then what you can do is you construct a portfolio that has sigma. This means standard deviation or the risk, okay? That's the sigma here. If you make a sigma or standard deviation, the risk as 1%, that means you select very safe company stocks only. Then the best year from the average one, here average one, the highest possible is 3 times sigma, 3 times risk 1%. That means 15.3. The best year you will have 15%, while others enjoy 73%. But when others cry a lot, losing almost half, right? Your investment is still positive, 12 minus 3, that's 9%. Still you are enjoying positive return. So you limit your earning chance, but losing chance too, okay? That's how you can construct safer portfolio than other people. But again, high losing chance is not there, but high earning chance is not there too. Then the concept, average return, return volatility, and risk premium. The average return, we use arithmetic mean. That means simply add those year by year, 1 year, second year, third year, adding all divided by 3 because we have 3 years, then 10%. Stock Y, to the same one here, divided by 3, we have 10. However, from here we know stock X, average 10, and all 3 numbers clustered into what? Around the 10. 10, 2 below, 2 above, all around the 10. Versus stock Y, average is 10, but this is 10% higher. This is 15% lower. This is 5% higher. So this guy, Y, has more up and down. So in the future, you expect what? This guy more volatile than X. So return volatility, using this average versus each guy, we can see which one is more volatile. Okay. So we use a volatility formula or variance formula and then take a square root, and that makes a standard deviation. We'll do a little later the calculation. And risk premium, the concept, risk premium, that's the difference between risk assets return versus risk-free asset return. Since we don't have risk-free asset, we use government's treasury bill as proxy. Okay? Suppose treasury bill 4%. Nowadays it's not 4, but if treasury bill pays 4, then this is risk-free, you can get 4%. But if you invest your money into company A, that means every company has a risk, and suppose you can get 10, then the difference is 6%. 10 minus 4, that's 6%. From treasury bill risk-free asset to risk asset, you add 6% more. So this 6% is premium for taking risk. Okay, this is risk premium for the stock investment. Then in chapter 11, we will do actual calculation and eventually end up capital asset pricing model. So expected return, variance, and covariance concept. Expected return, that means the future, we don't know, and future return we calculate. That's weighted average of all possible returns in the future. So we have 3 chances. Boom chance is 20%, normal chance 40%, recession chance is 40%. If that's the one, how we can get the chance? Typically, we use those economists who are forecasting. So suppose we have a pool of 100 economists who forecast the future. Then among them, 20 people say we'll have a great year next year. And 40 people say, no, similar to this year. The remaining 40 people say we'll have trouble. That's how we can get this probability of states. And then return on asset A or stock A. Boom happens, then you expect 25%. Normal happens, then 10%. Recession happens, then losing 10. If that's the case, then the expected return means weighted average. What this means, we multiply the boom weight, that's 0.2, times 25%. Boom weight is 0.2, and then boom happens, then 25. This one is normal chance, and then 10%. Recession chance, then losing 10. So we add all those 3 guys. That's a weighted average, okay? Then you'll have 5%. So from the table, what you do, 0.2 times 25, 0.4 times 10, 0.4 times minus 10. Adding all 3, you're going to end up 5. For B, you do the same, okay? 0.2 times minus 5, 0.4, 5, 0.4 times 20, and add all of them, you will end up 9. So compared to asset A and asset B, or stock A or stock B, which is better? B is better because higher. Never say that until we calculate risk. Every time you have to check return and risk together to make valid decision or correct evaluation. So the variance, that's the volatility of the possible return. As we mentioned in chapter 10, the volatility of the stock, right? Return. So we use probability we use, and then from the average return, we subtract each guy, okay? Average return and each guy, how far away from. So A, we have average 5%, right? This is average return or A return. And then boom, 25 means from 5, 20% up. Normal 10 means 5% above average. And minus 10 means 15% below average 5. That's what we do in calculation and add the weight of boom normal recession. So boom chance 0.2 is the weight. And then boom chance return is 25, average is 5. 25 minus 5. This one lets you know the difference or the distance is 20% above, right? And we do power to 2. And 0.4, that's a normal chance, 0.4. And normal case, 10%. This is 5% above average. 5 is average, and 10, that's 10 minus 5 is 5, right? And power to 2. Why we do power to 2? Because of the sign effect. If you don't do power, but simply you do 25 minus 5 times 0.2. 10 minus 5 times 0.4. And minus 10 minus 5 times 0.4. Then you will have 0. Because the plus minus will be cancelled out. That we call sign effect. So the only way we can ignore the sign effect, that's we simply power. Minus power to 2 change to positive, right? So we power to 2 to get the variance number. Okay. So the recession, 0.4 the weight, and recession we have 10% losing, average is 5. So minus 10 minus 5 ends up minus 15. That means from the average 5, minus 10 means what? 15% below. So this captures 15. Then we ended up 180% as variance. Remember, we did power to 2. Okay, we did square, we did power to 2. That's the variance formula. Then after get the variance number, we take a square root. Okay, we take a square root. Since we did the power to 2, we take it back to square root. That's we call risk or standard deviation formula. Okay, so this is variance is sigma square, and take a square root. The remaining is what? Sigma. Okay, so let's add here. Oops. This is the variance. Then at square root sigma standard deviation. Okay, I don't have a space, so leave it there. After square root, we have a sigma. That's a standard deviation used for risk measure. Okay, so asset A, risk is 13.42. Asset B, I ask you to calculate this. Okay, how you do? You do 0.2 times. For B, average is 9%. So in case of boom losing 5, you do minus 5%. Oops. Here, 0.2. And then you do minus 5%. Minus, the average is what? 9%. And then you do power to 2. Plus, you do the same. Okay, then you're going to end up, and final answer as 94. Okay, you try this way, and you should have 94% as SFB variance. I will delete again. Then, after you get variance 94, square root, you will have 9.7. Now we can summarize here. Look at here. Return on asset A 5%, B 9%, so B is higher. But we said we never conclude until we see the risk. And when we check the risk, A risk is 13, B risk is 9.7. What this means? B has more return and less risk. Typically, it doesn't happen, okay? More risk, more return. So in this case, definitely B is better than A. Return more, but taking less risk. It's super better. And anytime same level of expected return, then higher the standard deviation is riskier. But we have a different level here. So if the expected return is different, then we use a CV, okay? Coefficient of variation, or we call the CV. That's we use the risk above and then return bottom, okay? Risk over return ratio, that's a CV, risk over return. Risk is 13.4 and return is 5. So 13.4 over 5 is 2.7. That's the CV, coefficient of variation number. For B, you can do the same way. Risk is what? 9.7. Divided by 9, you will end up 1.1. Okay, that's how we got 1.1. So clearly now we see what this means. Actually, this is over 1, okay? And this one also over 1. So the formula, what we did, that's the risk over return. Per 1% return, your risk size for A is almost 3 times more. But for B, 1% return, your risk taking is 1.1, little above 1. Okay? So not exactly, but this B is 3 times, almost 3 times safer than A, or better than A. Because the same 1% return, the risk is only little over 1, but this is almost 3. Okay? So this example is very obvious. But what if this asset A's return is not 5, but let's say 12.6 or 12.5? If this is 12.5, then 9, 9.7, 12.5, 13.4. It's a little bit hard to tell which is better, right? Then if you use CB, coefficient of variation, and then calculate, then exactly you can see which one is better than the other, okay? Then now move to portfolio. Up to now we did a single asset, asset A, asset B, how we can get expected return, how we can get variance, and standard deviation or risk. We just did. How about portfolio? Portfolio means more than 2 or more than 2 assets, 2, 3, 4 assets. In a portfolio, you're going to have at least 2 or more. So expected return, we can get, if we know A return, B return, then we can use the weight A, weight B. WA means weight of A, WB means weight of B. Suppose we have $100 million and 50 million in A, 50 million in B. That means WA, weight A, out of total 100 million is 50%. And the other half is in B. That means WB is what? 0.5 or 50%. That's the weight means. This is expected return A, expected return B. So since we know A and B return, right? Above here, A return 5, B return 9. So combining A and B, half the money in A return is 5. Let's see together. And half the money in B, okay, half of B, that's weight B, and then B return is 9. So half A invested in get 5. The other half B invested in get 9. Then average you will get 7. So combining A and B, your return will be 7%. The variance, we have a little bit crazy formula here, okay? But this one, we combine A's risk. Sigma A means risk A, okay? Actually this one. And B is a risk. We use a sigma, right, as risk. B is a risk is 9.7. So that's a sigma B. So here the formula, WA, that means weight A, we have a 50%, right? So 0.5 or 50%, power to 2. And then multiply A's risk. 13.42 is A's risk, power to 2. Plus B's weight, 0.5 square, and B's risk square, 9.7 square, plus 2, WA, 0.5, WB, 0.5, and multiply covariance. We have covariance here. Then we have 3.5466. Okay. So using this formula, we can get the risk of portfolio. Okay. This formula is similar to, this formula is similar to, but we're not going over thoroughly. If you do A plus B and square, if you do A plus B in the bracket square, okay, from your middle school possibly, that's A square plus B square plus 2AB. Okay, remember this is the one from your middle school you covered. A plus B square is A square, B square, and 2AB. So the portfolio variance, okay, that's adding two assets risk, A risk, B risk together, and then power to 2, sigma square 2, right? That means A square, that's we combine WA and sigma A square. That's actually this part. And WB sigma B square, that's the second part. And 2AB part is the second part. But it's not normal math. We have to consider covariance or correlation. That's the difference. But we are not going over thoroughly about that. And here, okay, here, investment class will cover that. Here, sigma P square. That means variance of P means portfolio, okay? Portfolio variance ended up 3.546%. Anybody notice that? Any shock? Look at here. Before A variance, asset A variance is 180. Asset B variance was 94. Both of them, this one almost 200, this one almost 100. Now we combine A's risk and B's risk, combining half and half. Then normal math, it should be around 150, right? Almost 200, almost 100. You combine the two half and half. Then your answer should be 150%. However, look at here. We combined A and B risk and weight, right? A and B risk combined one half and half, and answer is not 150 but even less than 10. It's just 3.55. And have to take a square root. That's the risk, right? We have 1.88. Okay, it has 1.88. Look at here. A risk 13.4 after taking standard deviation or square root of the variance. B is almost 10. 13 and 10, combining the two, we have only 1.88. That means what? Even less than 2. Okay, 1.88. That's what we call diversification effect. That's the next 8-2. We have that information, but now we see portfolio reduce risk a lot, right? Here. Then look at here, the covariance. In here we have a covariance formula, here, and then we have a number 130 minus. So covariance means how the two guys move together, how covary, how vary each other. And look at here, the variance covariance formula, 0.2. And first part is one asset's distance from average, 25 minus 5. That's 20. And this one, second guy, B, average return is 9. And then, boom case, losing 5. So minus 5 minus 9. Okay. So combining the two, plus here 20, minus here, and the minus, they move opposite direction. And normal chance is 0.4. First asset, 10 minus 5. Second asset, 5 minus 9. Third one, recession, 0.4. Wait, A lose 10 from 5 average. B gain 20 from average 9. So answer will be minus 130. That's a covariance measure. The same concept we use as correlation. That's covariance we divide by each guy's risk. Okay, if you do that, then covariance number is minus 130 we got here. And then sigma A or risk A is 13.42, right? Risk B is 9.7. This 9.7 B risk. Using that, we ended up 0.999 minus 0.99, almost minus 1. We don't cover here about investment class. We'll cover this one. It's almost minus 1. That's what we call perfectly negatively correlated. Another way, one guy is up, the other guy down. The other guy down, one guy up. The other guy up, one guy down. So they move opposite direction. Whenever you have opposite direction case, you will have the best result of portfolio. Another way, you can reduce risk a lot. Okay. So let's compare. A and B return, portfolio A, B half. So we ended up 7% as average return. However, the risk is 1.88%. We combine 13.4A, 9.7B, combine the two half and half. But answer is not normal math. Because of correlation or covariance number, this answer is way below the two guys' average. So if we calculate CV, this one 2.7, we did before, right? This one 1.1, but now combining A and B. Before, look at here, between the two, A risk and return, B risk and return, A and B, B is much better. So we should not combine both using normal math, right? However, in here, finance, we did a kind of dumb thing, stupid thing. That means we should not invest in A. We should invest everything in B, but somehow we did half in A, half money in B. We did half and half investment. Then, normal case, we should not expect a better result. But this one, because of the asset A and B behavior, asset A, B move, okay, covary, the movement is opposite, so we have amazing results. We don't lose much, okay? Combining A and B, we have a 7% return. Not bad, but the risk is way, way below. What this means? For the single 1% return, for single 1% return, the same 1% return, okay? First one, A, 2.7% risk we have to take. B, we have to take a little over 1. But combining the two, okay, for the same 1% return, our risk taking is much, much less than even B. B was a better one, but now combining A and B half and half, this is much better than even B. That's the diversification effect or portfolio benefit.